Hello all. Our next type of interface is garbage collector interfaces of RMI. The distributed garbage collector DGC for the RMI uses the interfaces and classes. For the server side of the distributed garbage collection process, the DGC abstraction is employed. There are two methods in this interface. First one is dirty and clean. When a remote reference gets unmarshaled in a client, it is referred to as a dirty call. The client is indicated by its VM ID. When there are no more references to the remote references in the client, a clean call is made. A failed dirty call must schedule a strong clean call so that the call's sequence number can be saved and used by the distributed garbage collector to detect subsequent calls received out of order. The client holding the reference leases a reference to a remote object for a set amount of time. When a dirty call is received, the lease period begins before the leases expire. The client is responsible for renewing the leases by making the additional dirty calls to the distant references it has. The distributed garbage collector considers that the remote object is no longer accessed by the client if the lease is not renewed before it expires. Let us consider the example for the garbage collector interface. Let us consider the program package java.rmi dgc import java.rmi server opt id public interface dgc extend java.rmi.remote lease dirty opt id IDs long sequence num lease throws java.rmi remote exception void clean opt id IDs long sec num vmid boolean strong throws java.rmi remote exception. This is a program or example represent how we can use the garbage collector interface. Then our next topic is writing distributed application with RMI. Remote method invocation RMI is Java's implementation of object-to-object communication among the Java objects to realize a distributed computing model. RMI allows us to distribute our objects on various machines and invoke methods on the objects located on the remote sites. RMI applications are usually made up of two parts, a server and a client. A typical server program generates some remote objects, make reference to them available, and then waits for the client to invoke method on them. A typical client application obtains a remote interface to one or more server-side remote objects and then call methods are those objects. RMI is the mechanism that allows the server and the client to communicate and exchange the information. A distributed object application is a term used to describe such an application. Distributed object application must be able to communicate with each other. The example also shows how the RMI system loads the class byte codes for the object from the server to client and client to server using the existing web server. First, how we can locate the remote object. Applications can use one of two mechanisms to obtain the references to remote object. An application can register its remote object with RMI simple naming facility. The RMI registry or the application can pass and return remote object references as a part of its normal operation. Then remote object can be communicated with. Details of communication between remote objects are handled by RMI. To the programmer, remote communication looks like a standard Java method invocation. For objects that are passed around load class bytecodes, RMI provides the required method for loading an object's code as well as delivering its data because it allows a caller to pass the object to remote object. An RMI distributed application that uses the registry to gain a reference to a remote object is shown in the diagram below. In this diagram, to associate or bind the name with a remote object, the server calls the registry. The client searches the server's registry for the remote object by the name and then invoke a method on it. The example also shows how the RMI system loads the class bytecodes for the object from server to client and client to server using an existing web server. Then our next topic is how we can creating the distributed application using RMI. There are the general steps while using the RMI to create a distributed application. We are follow the following steps. First one, design and implement the component of your distributed application. Second, compile sources and generate stuff. Third one, make classes network accessible. And last is the start the application. We will discuss in detail one by one. First one is design and implement the application components. First, decide on your application architecture and determine which component are local object and which one should be remotely accessible. This step include first defining the remote interface. A remote interface specifies the remote method that can be invoked remotely by a client. Clients program to remote interfaces, not to the implementation classes of those interfaces. Part of the design of such interfaces is the determination of any local object that will be used as a parameters and return values for this method. If any of these interfaces or classes do not yet exist, you need to define them as well. Then how we can implementing the remote object. Remote object must implement one or more remote interfaces. The remote object class may include implementation of the either interface, either local or remote, and other methods which are available only locally. If any local classes are to be used as a parameters or in return values to any of these methods, they must be implemented as well. Then how can implementing the clients? Clients that use the remote object can be implemented at any time after the remote interfaces are defined, including after the remote objects have been deployed. Then second one is compile sources and generate stuff. This is a two-step process. In the first step, you use the Java compiler to compile the source files, which contain the implementation of the remote interfaces and implementation the server classes and the server classes and the client classes. In the second step, you use the RMI compiler to create stuff for the remote objects. RMI uses a remote object stuff class as a proxy in the client so that clients can communicate with a particular remote object. Then third step is make classes network accessible. This step makes everything accessible via a web server, including the class files associated with the remote interfaces, stubs, and other classes that need to be downloaded to clients. Then fourth step is start the application. The RMI remote object registry, the server and the client are all started when application is launched. This is all about the how we can creating the distributed application using RMI. Then our next topic is naming or registry service. When the server process want to provide a client with an RMI based service, it registers one or more RMI enabled object with its local RMI registry. Each object is given a unique name that clients can use to refer to it. A client can get a stuff reference to a remote object by using a naming interface to inquire for it by a name. The naming lookup method accepts a distant object fully qualified name and locates it on the network. The fully qualified name of the object has a URL-like syntax that contains the object's host name as well as object's register name. It's worth noting that while the name interface is a built-in naming service, it's not the only one available in RMI. The RMI registry can be tied into other naming service by vendor. Through the Java naming and directory interface, Sun has supplied a binding to the RMI registry. After locating the object host, the lookup method accesses the RMI registry on the host and requests the object by the name. If the registry discovers the object, it creates a remote reference to it and sets it to the client process, which converts it into a stub reference and returns it to the caller. Communication between the client and the server begins as stated before once the client has a remote reference to the server object. A flat namespace is supported by the RMI registry. Every name is atomic. Since there is no hierarchy, each name can be made up of any number of characters and case matter. Names are supplied as a parameter to registry context method and the result of those methods are written as a name object or string. When using a name object, it should only have one component, the value of which is the atomic name that will be provided to the registry. A string is regarded as the string representation of a composite name when it is used as a name. If cont is, for example, a registry context, the following two unbind actions are equivalent. That is string name hello cont.unbind name, cont.unbind new composite name name. Name containing any of four meta characters that are treated differently during the composite name preceding slash, double, left or right. These characters need to be quoted or escaped properly. To avoiding being confused with the two component name with A and B as its component, the atomic name A or B, for example, can be represented as the composite name A, B, B. This is all about the naming services. Then next topic is naming and directory service. The Java Naming and Directory Interface, that is Jndi, is an application programming interface API that provides naming and directory functionality to application written using the Java programming language. It is defined to be independent of any specific directory service implementation. There are few difficulties such as locating the correct phone directory, but it's fundamentally a straightforward process. The naming service is a service that allows you to give the object name so that you may obtain or utilize them without knowing where they are. Object can be found of any system that is connected to your network, not just or local workstation. The phone directory is a real world example. It keeps the track of your phone number with the name and addresses. Finding people's phone number is as simple as identifying as entry in the phone book using their name and potentially address and retrieving the associated phone number. There are the few difficulties such as locating the correct phone directory, but it's fundamentally a straightforward procedure. Naming service, by the way, have a similar challenge to finding the proper phone directory. Obtaining a context in a term for this. Only by looking at the correct context you can find a name phone book. A directory service associated name with the object as well, but adds value by associating attributes with the object. A simple instance of a directory service is the Yellow Pages phone directory. Business frequently include extra information in their advertisement, such as a list of products sold, professional qualification, link organization, and even directions to their location. The value of the name entry is increased by this quantity. The directory service will usually allow you to search for entry with a specific attribute or values for attribute. This is the analogous to looking for anything on the internet. Yellow page style phone book also store the names under category. For example, hairdresser or lawyers. Categorizing entries can simply searching for the particular type of entry. These categorized entries are the form of sub-context within the directory context of the local phone book. Let us consider the figure of naming and directory service. In this table, you can see the level of architecture. All the levels of architecture are connected to the Java application. The API provides a mechanism to bind an object to a name and to access the naming and directory services. The SPI allows naming and directory services to be plugged in transparently. The last level shows the directories that are connected to the interfaces. This is all about the naming and directory services. Then what are the benefits of using naming or directory services? Naming services are the essential technique for separating the provider of a service from the service client. A naming service allows a service provider to register their product with a name. To use the service, users or the client just need to know the name of the service. Consider how difficult it would be to find someone's phone number without using the phone book. To get your friend's phone number, you will have to go to their house and ask, or you will have to wait until you see them again, which may be tough to arrange because you can't call them to set up a meeting. These are the benefits of using naming or directory services. Then what is Jndi? Jndi is the Java API that defines the Java interface to naming and directory services. Jndi is an API, not a naming or directory service in and of itself. A naming and directory service implementation must be available in order to use Jndi. The underlying service provider implementation is accessed by Jndi, which provides a service-independent interface. The Jndi layer interface between the Java program and the underlying naming services. We are already seen in figure. The service provider interface, that is SPI for Jndi, can be used to plug in addition naming services to the Jndi layer. This is all about the Jndi. Thank you all.